it is no secret that native languages like Rust and Golang are powering lots of tooling in the JavaScript ecosystem. You have tools like SST and esbuild, which of course are written in Golang, and others written in Rust, like TurboRepo, modern versions of Next.js which use TurboPack, and even Vite itself is joining the party with future versions intended to be powered by Rolldown. And of course, performance is often cited as the reason behind this. But how does it work? Well, you start with a compiled language, with Rust and Go being more popular, but technically you could use any compiled language including Zig, which will be awesome. Then, once you've written your CLI, you cross-compile it across all the different operating systems and architectures that you intend to support. So, a commonly used example, you could choose Linux, Darwin, and Windows across x86 chips and ARM64. And here's where it gets cool in my opinion. You publish all of these binaries as NPM packages, but in the package.json, you make sure to specify this CPU property and the architecture property. You do this for all the different binaries. You might think it's tedious to do this manually, which it is, so at the end we'll take a look at a tool that simplifies all this. Then, in your main libraries package or CLI, you list all of the specific binary packages as optional dependencies. What NPM or your package manager of choice does when installing the CLI is it skips any packages that don't match your CPU arch combo, so you only end up with the one that works for you and that was built for you. So when you invoke a CLI like SST, it's going to look for the binary entry in the package.json, which itself leads to a shim file executed by Node, which itself runs some logic to find the binary that matches your setup. So for example, calling require.resolve here finds the executable at this path shown on screen. And of course, there's some error handling, but assuming everything goes well, then the binary gets spawned as a child process. And going back to the process of publishing and managing all of these different packages across all these different OS and architecture combos, that's where tools like Go Releaser come in. I mean, it has Go in the name, so you can imply it was heavily used for that, but it now supports other languages including Rust, Zig, etc. And that's it.